Hey, hello, welcome to the show. It's me, John Park, and this is JP's product pick of the week. And I just wanted to go and check and see why the heck Facebook doesn't seem to be wanting to connect. It says connect streaming software to go live. I've tried Facebook, I really have. Their advanced settings, who knows? Well, I'm so sorry if you were trying to watch this on Facebook. It's just not happening. I don't get it. But I think we're live over on Twitch and YouTube and LinkedIn Learning and possibly a few other places. YouTube being the big one, as you could probably guess. Speaking of YouTube, thanks, hey, for stopping by over in our chat over there. We got Tackle the World and Doug TDY892 Smile Emojicon. Hi. KC and Jeff McAvoy. Hello, hey, hey, hi, hi. Do you know that there are words to the JP Product Pick of the Week theme song? I don't know if there are. I'm not aware of any, but please submit some. I'll sing them along. Over in our Discord chat, that's where it's at. If you are somewhere without a chat, go check our Discord out. You can go to adafruit.it/discord and then look for the live broadcast chat channel right there. Hello, C. Grover, Uniscu7, John Nodge, Thin Man, Paul Cutler, Jim Hendrickson, and Blitz City DIY. Hello, hey, thanks for stopping by. We have a pretty groovy little product here today. I'm excited to show it to you and demo it for you. Before I do that, though, let me tell you where to go. If you want to go get a jump start, throw some in your cart, get it for half off. This is how you do it. Go to that QR code or that uniform resource locator right there. Type that into your browser. Tick, 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 tick. You should see, I'm going to double check the product at a 50% off. Yes, indeed. I think we had 100 of these stashed. There were a few others before that, but we have about 100 of these. And you can go there and get it for a tremendous savings today. And you don't need a coupon code or anything. It's just going to be priced during the show, during the live stream only at that half price. Also, this show is broadcast from inside of the product page right there. So if you want to go there, you can watch inside there if that's convenient for you. Instead of doing multiple windows, you could do a tab inside of or a window inside of a single browser page. But before I say any more, what I'll do is let Lady Ada tell us about this from her new segment on Ask an Engineer. So please take it away, Lady Ada.
We put in the DAC 7578 like a week or two ago, 12-bit DAC. It's a little pricey. Look, it's what it is. It's a really great analog devices chip. Sorry, TI chip. Don't sue me, ADI. But now we have it with the 10-bit version, which is a lot more affordable. And for many use cases, 10-bit is perfectly fine. 12-bit is actually when DACs get a little bit expensive. I2C control, 8 outputs. You can use, pretty high-speed I2C. It's kind of one of the only 8 output DACs. So you can do a full octave of voltage control.
That's right. That's a short one, so it caught me off guard. I forgot. That is the product pick of the week right there. It is the DAC 6578 10-bit 8-channel I2C digital to analog converter Breakout. So this uses STEMMA QT over I2C so that you can communicate with it easily from your microcontroller project. And I'm going to pull up a little image here so you can see on the back we have an address jumper that allows you to pick up to 3 different addresses for this. So you can share on a single I2C channel 3 of these and have a whole slew of DAC output going all at the same time. We also have a jumper on the back there that allows you to cut the LED if you don't want the little green power LED lit up. Or is it I think there might be is there a red LED when it's active? We'll check and see. I can't remember. I have mine paused at the moment. What else do you need to know about this? So this is 8 channels of analog. So you have 10-bit digital information on your microcontroller headed to those channels, which then travel out as analog signals. So they're great for experimentation, scientific analysis. I'm going to use it for, big surprise here, a Eurorack synthesizer sequencer. So you're not going to drive a big load with these, but you are going to get accurate analog signals coming out of what you send it. So let's take a look, first of all, at the product page here. So this is it on product page 6258. And you can see right now we have both a 10-bit and a 12-bit version. Like Lady Ada said, they get pretty pricey at 12-bit. It's almost double the price of the non-discounted one. But right now, discounted, this is $7.48, so a really nice bargain. And it really just depends on your needs. Do you need the 12-bit DAC precision, or are you okay with 10-bit? This actually works out pretty well in this synthesizer example. We're going to be using it for control voltage for pitch. You could use it for things like an LFO. I'm also going to use it as an envelope generator on 4 channels. So you can also pick up some STEMMA QT cables for this to chain multiples of them, or just connect a single one to your microcontroller. If you take a look at some of the stats on here, so we've got 8 channels. There are 10-bit signals. This will run at, you can give it anywhere from about 2.7 volts to 5 volts to operate. It will work with 3.3 volt logic or 5 volt logic. I'll be using a QT Py, which is going to be at 3.3 volt logic in my example. You can also give it a reference voltage up to whatever you're using to run the board and your logic. You can give it a separate reference voltage somewhere in that 0 to the top of your logic level voltage range if you have an external reference. And then we also have pins for soldering this. You can see in the image there. Scroll back up. Let's go to that image right there. Or in fact, let's go to Learn Guide where you can see the pinout. This will show you, actually I liked that big photo right there. This will show you we've got a pin for the voltage reference. You've got the 0 through 7 channels, so those are the 8 analog signals that are coming out of this, as well as the common ground that you'll share. And then at the bottom there we have the connections for your incoming voltage. If you're not using a separate reference voltage, that's the only one you need, as well as ground from your microcontroller, and then the I2C connections as well. So if we do go to the pinout page, you can see a couple of extra pins there. I'm not using these in my project. They are the load DAC pin, which is used for synchronous or asynchronous updating of the DAC outputs. I haven't used that. And then there's a clear pin, which clears the DAC registers and buffers, and I haven't needed to use that in my example here. This gives you a little idea of the addresses that you can pick when you adjust the jumper on the back there. So you can use these on a crowded I2C bus, or just to use 3 of them or 2 of them. As well as, so there's info there on the power LED. It'll light up green when it's got power, and then there's a red LED that will light, I believe, when a signal is sent. So thanks, by the way, to Liz for putting together this excellent guide. It has examples for setup in CircuitPython, as well as a little wiring diagram, and in Arduino. And then we have the downloads page, which takes you to the fritzing diagram, CAD files, the chip data sheet. So what I want to do for a demo here is, let's jump to this downshooter view here so I can show you what I have going on. It's a little far away just because I have a lot in the picture, and unfortunately I've got a lot of jumper patch cables here in the way. So here you can see, hopefully, there is my STEMMA QT, and I'm actually going to boost the exposure here just a little bit. That's a little brighter there. You can see here is my DAC. It's the DAC 6578 Breakout. It's connected over I2C. And then I've just run common ground and each of those analog pins to their own jumper or socket there, so that I can use patch cables. So these are little mono breakouts here. So I've plugged in patch cables to those. Those are then running up to different channels on this little Eurorack synthesizer case I put together. If you want, take a look in the upper right-hand corner here. This is a little small 2-channel oscilloscope. So that's going to show us, I believe, channels 0 and 4. Yeah, 0, 1, 2, 3. Yeah, 0 and 4, I believe. So 0 I'm going to use, in this first example, you'll see a slower sine wave moving across, and then a faster one on the second channel, which is going to be the lower one. So what I'll do is, we'll take a look at code in a second, but first let me just start it rolling so you can see. So this is the output of the DAC right now. I'm not playing any sound from it, but this is the visual representation on a small scope of that analog signal. So you can see we have this nice smooth sine wave at the top and then a faster one at the bottom. Now what I'll do is bring up the audio. Okay, so that should just be that first sine wave that we're hearing there. And if you can take a moment to let me know if you're able to still hear me and the audio there. I've mic'd a little amplifier, so hopefully you'll be able to hear that. Let me know. I'll take a moment here to make sure that I'm not drowned out entirely. It's confusing the cats. I'm so sorry. Yeah, let's drop the octave there. That's not as annoying. Yeah, let's go much lower. How about for now on that? Okay, you can hear both. Thank you, Tackle the World. Thanks, Jim Hendrickson. Okay, so now second channel is actually the same signal, and I have two oscillators here tuned the same to begin with, but let me drop that, the octaves too. But it's going to go twice as fast. So you can hear that faster one and the slower one happening at the same time. So that is two oscillators. What I'm going to do next is bring up just that first one. And I'm using, like I said, this green cable here. You can see that's channel 4. That is going to be a much faster one. So we're going to kind of hear the volume going up and down quickly. So this is this channel 4 here. Okay, so what does this look like in code? Let me bring the levels back down, and we'll take a look at the IDE here. And hopefully I've got a somewhat more pleasant audio experience for you coming up. But this is the code I'm running here, which is Liz's example code from the Learn Guide. So you can see it's pretty straightforward. We're using math to be able to generate those nice sine waves, time for timing, board for board definitions, and then we're importing DAC X578. So we use the same library for the 6578 and the 75, or whatever that other one, the 12-bit one's name is. And then you can see I'm setting up I2C over the stemma cable. You could also use the pins there on the board by removing this little bit of code. And then the DAC is being established here on I2C. We're setting up the maximum value. So CircuitPython uses 16-bit internally, even though this is a 10-bit DAC. The conversions happen under the hood in the library. But so you don't think that we're getting this full range here. It's going to be a stepped version inside of this 16-bit because it's actually 10-bit. And then we have a base frequency in hertz to start with and a sample rate. And then these are the multipliers, so each of them is going to increase from the first one, and that's why the slowest channel here was channel 0. And then they get faster and faster as they go. And then here's this creation of the sine wave, a start time, so we keep track of time. And then in each of the channels, the next output is set. So to write those out, it's simply creating the value and then DAC channels, channel number dot value. So you can just write an analog value out by setting that DAC channels number and a value. So what we'll do now is take a look at a more complicated example. I'm going to grab something I made over the weekend, which is a sequencer. And it's probably best to play it before looking at the code too much. So let me resave this. And then I'm going to bring up the 4 channels. Take that one out. That one went out of tune. I bumped a knob. So, okay, what we're hearing is 3 different channels of pitch control voltage coming from this, and 3 different channels of the envelope generator, which is what's opening and closing or playing the notes, allowing us to hear them and then not hear them, essentially turning an amplifier knob, you could think of it as. Let me try to make channel 3 sound a little better here. I'm going to switch it to a percussive. There we go. So at least for demonstration purposes, we now have 4 channels of control voltage coming here, playing 4 different notes, and we have 4 channels of that amplification. If you look over here at, lower this volume for a second, just the overall volume. If you look at what's going on in my little scope here, again, this is still just checking the first channel, channel 0, and the 4th channel. We're seeing stepped voltages. Let me see if I can. I'm not sure if I can. Yeah, I don't think I can get that camera over there without breaking something. But you can see the top line there is kind of a shallow set of steps, and that is the pitch changing within an octave. In fact, if I turn just the first one, you might be able to see the pitch, the relative pitch going up and down of that note. And the bottom is the envelope. So each time a note happens, it kind of spikes, then gets a little quieter, then drops off. And that's essentially the envelope, the attack, decay, sustain, and release of the note being played. And bring two of these in together. And at the end of the day, what's most important here for this demonstration is the DAC output playing those 4, or actually 8 different analog voltages out over these 8 channels here. Let's see if I can find it. So voltage to DAC value, and this is where we're doing the conversion so that we have a number that we can send out based on this 1 volt per octave Eurorack standard we're using for the sound. And then I've got some convenience variables and things in here, like we can say, you know what, let's just only play quarter notes. And I'll stop having any rests in there at all. Right now it's resting about a third of the time. Okay, so now we're just hearing a regular pulse, and you can see over here in the oscilloscope, in fact, we can go to a full view of that for a second. You can see here in the oscilloscope I've got a note per and a attack, attack decay, sustain release per. And if I change, let's go back to the code view, to, let's say, a random fast, we'll get quarter notes and eighth notes. So you can see on those held notes it's a little longer. It's twice as long, in fact, on the scope there. You can bring this octave up. And then I've got some other conveniences in there, like scales. We can do, let's say, a major scale instead of a pentatonic. John Nudge says, I think I played this video game a long time ago. Yeah, if we crank the speed up and play little arpeggios or fast little notes, we get an arcade sound. Especially with the inclusion of a little sizzle, little noise track as the drum track in there. Yeah, that one's impossible to do. All right, I'll stop that there. Let me wait for a pause. Nope, I'll just turn the volume down. It doesn't have a way of stopping the note otherwise. So pretty cool though, the fact that you could make an 8-channel sequencer in a little microcontroller. Again, this is running off of a QT Py in CircuitPython. And we have 8 channels. You can string 3 of these together. Right now, they cost about $8 during this 50% off madness we're doing during the show. So if you've ever thought about making yourself a pretty darn capable little sequencer for control voltage, you of course could use it for all sorts of other things. You're not going to drive a lot of current with it. However, if you wanted to do analog meter stuff, if you have some little analog meters and you want to drive needles around, you can get them to sweep, you can get them to bounce around. There's all things that you could do with this little board. Let's see. Any questions? Let me just check the chats. Looks like we're good. So we can finish this up then. This right here is where you want to go to check it out. It is product 6258. Let's see if we have them in stock here before I oversell it. Yes, 91 of them in stock. Okay, good. So we have plenty in stock. Go ahead and throw some in your cart. Grab some cables, maybe a little cutie pie to go with. Do some cool stuff. Let us know what you do with it. I think, unless there's other questions, we can wrap it up right there. So that is my product pick of the week this week. It is the DAC 6578. It is an 8-channel, 10-bit digital to analog converter Breakout with I2C. For Adafruit Industries, I'm John Park. This has been JP's product pick of the week, and I'll see you next time. Thanks, everyone. Bye-bye. Oh, should I play us out?